Today we will going to discuss matrices. What is matrices? A set of real or imaginary numbers arranged in the form of rectangular array. A set of real or imaginary number. A set of real or imaginary number arranged in the form of rectangular array of m rows and n columns is called m by n matrix. Okay, a set of real or imaginary numbers arranged in the form of rectangular array of m rows. Here m rows means horizontal rows and n column means vertical columns is called m by n matrices. So it is denoted by a is equal to a11, a12 up to a1n. So a11, a12, a13, a14 up to a1n. This is called horizontal rows means m rows, and vertical elements of matrices are called columns. 21, 22, 23 up to 2n. So this continues a m1, a m2 up to a mn. So these vertical elements arranged in a matrix is called column, and the horizontal elements of matrices arranged in the m rows. So A is equal to matrix A having order m by n. M is row and n is column. This is the definition of matrices. Now types of matrices. What are the types of matrices? Let us see. First type is rectangular matrices. Rectangular matrix. Here number of rows is not equal to number of columns. Number of rows is not equal to number of column, means m is not equal to n. This is the condition of rectangular matrices. It is denoted by a is equal to a having order m by n if m not equal to n. Number of rows not equal to number of columns. This is the condition of rectangular matrices. It is like that: a1, 2, 3, 4, 2, 1, 2, 4. Here we can say The rows are two. This is one row, this is another row, and columns are 1, 2, 3, 4. So 2 by 4 matrices. Order of the matrices is not same. This is called rectangular matrices. Another matrices type is row matrices. As the name indicates, it contains only row, no columns. A is equal to 1, 2, 3, 4 up to n, up to m. We denote rows by m. So m equal to 1. So matrix is denoted by A, m by n, where m is equal to 1 by n. The column may n, but row must be 1. Row must be 1. This is row matrices. Now another type is column matrices. As the name indicates, it contains n columns. It contains n number of columns. Sorry, n number of rows, only one column. Only one column. Here in a row matrix, only one row, n number of columns, and in a column matrix, only one column, n number of rows. It may be a 1, 2, 3 up to n. So it is denoted by a equal to a m by n, where number of columns are 1, m by 1. This is the column matrices. Now another type of matrices is a square matrices. Square matrices. Square matrices means the number of rows and columns are equal. M is the row, N is the column, and both are equal. It is called square matrices. As matrices general form M by N, where M is equal to N, M equal to N. This is a square matrices. A is equal to 2, 4, 3, 1, 2, 1, 3, 4, 5, etc. Here we can count the rows 1, 2, 3. Horizontal rows 3 and vertical columns are 3. So 3 by 3 matrices, 4 by 4 matrices, 5 by 5 matrices is called square matrices. Next type of matrices is diagonal matrices. Diagonal matrix. A square matrix in which all non-diagonal elements are 0 and at least one diagonal element is non-zero is called diagonal matrix. A square matrix. Note For diagonal matrix, the matrix should be square 1. For diagonal matrix should be square 1. So a square matrix in which all the non-diagonal elements are 0 and at least one diagonal elements is non-zero is called diagonal matrix. It is denoted by A is equal to 2 comma 0, 0 comma 1. Here rows and columns are equal, hence it is a square matrix, and diagonal elements means 2 1. This is the diagonal element, and these diagonal elements, non-diagonal elements, are 0. 2 and 1, except 2 and 1, all the elements are 0 in a diagonal elements. Another matrix of diagonal matrix is A is equal to 1 0 0 0 1 0 0 0 1. Here also the number of rows and number of columns are equal, and 1 1 1 is a diagonal of the matrix, except the diagonal element, all elements are 0. This is the condition of diagonal matrix. Scalar matrix. Scalar matrix. Non-diagonal elements are 0. Non-diagonal elements are 0 and whole diagonal elements are equal is called scalar matrix. Here matrix B is equal to 1 0 0 0 1 0 0 0 1. This is the diagonal elements of matrices and all are same. Another matrix C is equal to minus 10 0 0 0 minus 10 0 0 0 minus 10. Here the diagonal elements are same, minus 10 minus 10 minus 10. What is difference between scalar matrix and diagonal matrix? In a diagonal matrix, the diagonal elements we can see here are same and different. It may be a same or different, but in a scalar matrix, the diagonal element must be same with its sign. Here positive 1, positive 1, positive 1, minus 10, minus 10, minus 10. So this is the difference between diagonal matrix and scalar matrix. Next matrix is zero matrix. It is a null matrix. It is a null matrix. All the elements are 0. All the elements are 0. Like matrix A is 0 0 0 0, matrix B is 0 0 0, etc. the all elements are 0. This is the 0 matrix. Next matrix is identity matrix. Identity matrix. In that all diagonal elements is equal to 1 and non-diagonal element is 0. Matrix A is equal to 1 0 0 0 1 0 0 0 1. This is the diagonal of matrix. See difference between scalar matrix, zero matrix and identity matrix. In a identity matrix, the diagonal element must be 1. In a scalar matrix, the diagonal element must be 1 or it may be a different. But for identity matrix, it must be 1 and all the elements except diagonal element, these are 0. This is the condition of identity matrix. The diagonal element must be 1, but in a diagonal matrix it may be a different or same. In a scalar matrix it may be a same or different with its sign. Next matrix is upper triangular matrix. Upper triangular matrix. In this, all the elements below principal diagonal are 0. So 1 1 1, this is called principal diagonal. This 1 1 1, this is called minus 10 minus 10 minus 10, this is called principal diagonal. So element below principal diagonal elements are 0 in a upper triangular matrix. Matrix C is equal to 1 2 3 0 5 7 0 0 2. So principal diagonal elements are 1 5 2 and below the principal diagonal elements, below the principal diagonal, all the elements are 0. So this is called upper triangular matrix. Note that in a upper triangular matrix, the principal diagonal element may be same or different, but the elements below the principal diagonal element, these must be 0. Here you can see this is principal diagonal and below the principal diagonal elements are 0, hence it is called upper triangular matrix. Consider another matrix B 1 2 0 0 5 7 0 0 2. Here principal diagonal element is 1 5 2 and below the principal diagonal the element must be 0. So this is called upper triangular matrix. Consider another matrix lower triangular. The opposite of upper triangular matrix is called lower matrix, lower triangular matrix. So a square matrix in which all the elements above the principal diagonal are zero is called lower triangular matrix. A matrix A is equal to 1 0 0 4 5 0 7 8 9. The principal diagonal element is 159 and this is called principal diagonal, and above principal diagonal if the elements are 0 is called lower triangular matrix, is called lower triangular matrix. Next matrix is symmetric matrix. Symmetric matrix, as the name indicates, the elements are symmetric. Means if the upper triangular elements and lower triangular elements are same, means they are mirror image of each other. They are mirror image of each other. A square matrix in which A m by n equal to A n by m is called symmetric matrix. Means the elements above and below the principal diagonal elements must be same in a symmetric matrix. Or upper triangular elements and lower triangular elements are same and they are mirror image of each other. They are mirror image of each other. Consider matrix A is equal to A H G H B F G F C. A B C, this is the principal diagonal element of matrix A. Now look the upper triangular and lower triangular elements. Upper triangular elements H G F and lower triangular elements H G F, both are same and these are mirror image of each other. It's called symmetric matrix. 12. Skew symmetric matrix. Skew symmetric matrix. Here principal diagonal elements are 0. Here principal diagonal elements are 0 and matrix A m by n equal to minus A n by n is called skew symmetric matrix. A is equal to 0, 2, minus 4, minus 2, 0, 3, 4, minus 3, 0. Look the principal diagonal elements. They are 0 and 2 is reverse of minus 2, minus 4 is reverse of 4, plus 3 is reverse of minus 3. Means the upper triangular elements opposite of lower triangular elements. The sign is opposites. This is called skew symmetric matrices. So this is the types of matrices that we have covered. Next lecture we will discuss the problems on matrix algebra, simple matrix algebra, addition, subtraction, multiplication of the matrices. Thank you.